This is BYU Math 112. In this video we will discuss textbook section 2.3, something like exercise number 39, which reads, show that the limit as x approaches 0 of x squared times the sine of 1 over x is equal to 0. Well, we know a couple ways that we can try this. We can try and directly substitute in the 0 squared times the sine of 1 over 0. The only problem with this is that 1 over 0 is not defined as a number, so I can't evaluate that to get something nice. The next thing I could try is to split them. Well, maybe if I do the limit as x approaches 0 of x squared, and I multiply it by the limit as x approaches 0 of sine of 1 over x. Problem is that this limit does not exist, so I can't do it that way. I've exhausted two ways. What's my third choice? Over here we have number 3, the squeeze theorem. If f of x is less than or equal to g of x, which is less than or equal to h of x when x is near a, except possibly at a, and the limit of f of x and the limit of h of x as that x approaches a are both L, then that g of x, since it's always between the two of them, must squeeze in and have the same limit. So what are we going to do with that? Well, the first thing to note is that the sine function, as long as x is not equal to 0, is bounded. It's always less than or equal to 1, greater than or equal to -1. So I can start there, and that looks something like I want for this squeeze theorem, but the middle doesn't look like my function, and so what I'm going to do is multiply by x squared. So on the left I'm going to have negative x squared, in the middle I'm going to have x squared sine of 1 over x, and on the right 1 times x squared just gives me x squared. Well, now I have the function that I want in the middle. There's my g of x. And so hopefully this is f of x, this is g of x, and this is h of x. So the next thing I want to check is, do my limits match up? Is the limit of negative x squared as x approaches 0 equal to the limit as x approaches 0 of x squared? In this case, they are equal. Substituting in 0 for both of those, I get 0, which works out very nicely. By the squeeze theorem, then, I know that the limit as x approaches 0 of x squared sine of 1 over x must also equal 0. Again, this trick right here is where we start. If you have a sine function, if you have a cosine function, those are both bounded by 1 and -1, and they're great places to start. And then you use your algebra to manipulate the middle to look like your function, and you work your magic. Check the limits. Again, this is an important step to make sure that the limit on the outsides are both the same, and then the limit on the middle will have the same value. So that's how we do something like exercise 39.